Morning class. So it's 9 a.m. Let's get started. Last week we have talked about arithmetic. In chapter 2, we have talked about arithmetic operation. Let's have a quick recap. So last week we were talking about plus, minus, times, and divide sign. And these are very quite simple. They are very similar to mathematics expression. But then also, we have a special one. We have a modular sign, a percentage sign. This one is to calculate the remainder, like after the left side is divided by the right side. So this this lesser being seen in mathematical expression, but very often being used in computer programming, like in C++ programming. And then we talk about assignment or increment, x equal x plus 1. And there's a shortcut for it. The shortcut for it is x plus plus and plus plus x. And they are actually quite different. And they are actually quite different. Also, another shortcut for it is a plus equal 1. This is exactly the same as a equal a plus 1. Exactly the same. While for minus would be minus equal, for multiplication would be this times equal, for division will be this slash equal, and for remainder would be this percentage equal. So these are shortcuts. And there's a list of operators which are available in C++ programming. This is the list. And it's really quite straightforward. Yeah, quite straightforward. All of these are just mathematical operator, and this one is less being seen, and this one are programming operator in C++. Also, we talk about relational operator. What is relational operator for? So from its name, you can see that it's for comparing something. Relational means like something is lesser, something is larger, or comparing whether they are equal. So relational operators, we have greater than, lesser than, greater than or equal to, lesser than or equal to, or equal and not equal. So actually pretty much very straightforward, also quite straightforward. And later we'll talk more about it, like to hands-on on these relational operators. We can use it to actually do something, utilize it to actually help in some logic processing. And what is the output of relational expression? So it's a Boolean value. The output is either true or false. So true or false can be represented by Boolean value. So it's a Boolean value. And a Boolean value is actually just either 0 or 1. So if it is the Boolean is true, then it is 1. If the value is false, then it is 0. When you print it out, true will be represented by 1 and false will be represented by 0. And we talk about logical operator. This is actually quite special. So there is a not operator. So we apply this in front of a Boolean. If this Boolean is true, after applying this not operator, the whole expression becomes false. If x is false, after you apply this not operator, the whole expression becomes true. And there is this AND operator. So for AND, for this AND expression to be true, both x and y have to be both true. And for how about OR expression? For OR operator, either one of X or Y is true, makes the whole expression true. And we use it very often in programming, in in C++ programming. So please get familiar with this kind of operators, not operator and operator and or operator. And specifically today, we will use them, think we use them a lot for today's class. So because later we are going to talk about if statement. So in if statement, always we are comparing something. We are doing some relational expression or a logical expression. So this will be this kind of operators would be very, very useful. And in case you can't find it, the not operator, an exclamation mark is on the upper left of your keyboard. And about the AND operator, AND operator is at this place, and OR operator is at this place. And then last week we did a little bit of this demo. So these are all the possible cases for not and or expression. For not 1, you get 0. For not 0, you get 1. For 1 and 1, you get 1. 1 and 0, you get 0. 0 and 1, you get 0. 0 and 0, you get 0. And yeah, so on. And you can see that if this looks up very weird for you, you can think of 1 as a true. So you can think of 1 as a Boolean value. 1 will be true. So not true will be 0, which means false. How about not 0? Not 0 can be represented as not false. So if something is not false, then it is true. So true will be 1. How about true and true? True and true will still be true, and true and false will be false. Like true or true will still be true, but false or false will still be false. And also we talk about operator precedence. If you have a long expressions and there are a lot of operators in between, you might get confused. Now, you actually need to know operator precedence so that you write your code correctly. But this, if you really have a very long expression, most of the time writing a very long expression is a bad practice. So a better practice is to cover them or wrap them with the parentheses. Something like this. If you have a long expression, 3 times 5 plus 2 divided by 5 equal greater than 9 times 7 minus. So let's say you have this kind of expression. It's better you wrap it in this actually it's called braces or parentheses. So this. And this makes your code cleaner and easier to understand and easier to maintain. Okay, this is all about last week's lecture. So today we'll talk about if statement. In programming, when there is a need to make a decision or perform a certain action based on a condition, we will use if statement. So if statement actually exists in many kind of programming language. For example, C and C++, of course, and is in Python, in Java, in almost any kind of programming language. Most of the popular programming language have this if statement. For example, if hot water, drink more, sorry, if hot weather, drink more water. So this is like a part in your program. So you can check whether let's say this hot weather is a variable. If this variable is true, then execute something. Execute this part of the code. Okay. So if got two conditions. So in your if condition, there are two kind of possibility. Either your condition is true or either your condition is false. So these are Boolean value. So condition, the if condition is a Boolean value. And so let's look at this graph. So first, if we check, is hot weather true? If it is true, then we execute something, drink more water. If not, maybe we execute something else. For example, we exit. And this kind of structure is called selection structure. An operation in computer mainly depends on selection structure to make decision. Okay. So how does program flow looks like in if statement? Let's say this is the start of our program. And first, after our program starts, we have encountered some kind of condition. For example, is the weather today hot? So this state is stored inside a variable. Let's say the variable is called hot weather. So we are checking, is hot weather true? If it is true, we can write some of our program statements here. And these statements, this part, covered by these curly braces, will be executed. And after this is executed, the if statement is end. And now this program will continue to execute other statements. How about in false condition? If this condition is false, they are also the if condition. The if statements is end, and this program continue to execute other statements. So how to actually write these if statements? It's very simple. First, write if, and then this, right? This parentheses. Wait, let me check. I forgot. Is this not parentheses? Yes, this is called parentheses. So write a parentheses, a pair of parentheses, and then your condition will be inside. And then open these curly braces and close it, of course. And you can write all your program statements here. So if this condition is true, the program statements in between of these curly braces will be executed. There's another example. If true, then print something. Then print it is a sunny day. So if this explicitly set as true, if this condition is always true, that means these statements will always be executed. How about this? This is a more realistic example. So always we have a variable. So given this variable, now we want to check some, based on the value of this variable, we want to execute some program statements. Now we can make a comparison. We can check if A is greater than 5, then we do something. Okay. Only if A is greater than 5. So in our case, A is 3, A is not greater than 5. So this will become false. And in the false condition, this won't be executed, and thus there is no output in this program. This is an example, a sample exercise from the platform. Later we'll go through it. Exception handling with else. So back to the previous example. If hot weather, then we are going to wear short sleeve. So this is the condition. Hot weather is the condition. And wear short sleeve is the action that we are going to do. And this is the program that we are going to execute. So how about other kind of conditions? Or if it is cold condition or there is another third condition, how do we handle this in our if statements? So we actually can handle this. If the first condition is not met, then there is an else statement that we can make use of. So if it is hot, then wear short sleeve. Otherwise, if it is not hot, then wear long sleeve. Let's say we want to execute this kind of condition. How can we do so? First, there is a condition checking. If this condition checking pass, which means it's true, we execute statement A. Otherwise, execute statement B. Okay, both of this statement A and statement B leads to the end of its if statement. And after this if statement is ended, we start executing other statements in our program. So this is an example of if and else statements. If a Boolean value, if true or false, print out something. So if true, then we print out A. Otherwise, if it is not true, then the else condition will be executed. So we will print out B. This is how we write it. If something happen, do something. Otherwise, else. Otherwise, do something else. And this is also one example. So we have A equal 3 and B equal 5. Now we are going to compare them. If A greater than B, do something. Otherwise, do something else. So in this case, A is 3, B is 5. So A is not greater than B. So we are going to assign the value of A to B. So now B becomes 3. And after this being executed, it jumps out of this if-else statements. So after this executed, the next line to be executed will be return 0. Okay. So wait, A is greater than B is false, so else will be executed. 3 is not greater than 5, so else statement will be executed. So in this case, if else statement is executed, after else statement is executed, so the next line it will be executed will be this return 0. This is also one of the sample homework in our platform. We'll go through it later. And there's another cases. So just now we talked about what if you have multiple conditions, you have two conditions. So we have if and else statements to handle two conditions. What if you have three conditions or more than three conditions? How can we handle this kind of situation? For example, in some scenarios, there might be more than two choices. But if it's sunny, have a trip. If it's rainy, going to enjoy a movie. If it's snowy, can be a snow walk. So if not any of the above, then we can take a nap. So there are 5 conditions here. So if there are more than 2 conditions, we can make, or there are more than 1 condition, we can make use of else if. This is a sample. Let's say we have a string sunny. Okay, we have a string weather. This weather has been initialized with a value sunny. Also, we are going to read in weather as well. So we are going to read in weather from the input. And if weather is sunny, print out something. If it's rainy, print out something. So you can notice that for first condition, we is a if statement. But for a second condition, we use else if. So this is how we write multiple conditions in C++. If a condition, and then your curly braces, else if another condition, and then a pair of curly braces, and then else if again, another condition, and then a pair of a pair of curly braces again. And if none of, and for the last case, there will be an else. In case any of the above does not match, then we execute this else condition. Okay. So this is a very, very common structure in C++. We use it very often. So make sure you understand this structure. If, and then else if, and then else. This is also one of the sample homework in our platform. Later we'll go through it together. This one as well. Okay. Next, we are going to talk about type conversion. What is type conversion? So there's a can look at an example. For example, why type conversion is important. Let's say we have integer 10. Also, we have integer a equal 10. We have integer b equal 3. And we're going to print out a divided by b. So what would the value be? Would be 3. It's not 3.33333. So why is that so? If you want to understand this, you need to understand type conversion. Or how could we make it 3.33? So we need to understand type conversion first. There's a question. So it's like my present. Can variables of different types perform operations on each other? So variables have different types such as integer, float, and character. Each variable types have different ways of storing data. And they have actually different sizes. Their storage have different sizes for each of their variable types. Therefore, when performing actual calculations, data of different types must be converted to the same format for computation. This is known as type conversion. Okay. And there are two types of type conversion. There's one called automatic type conversion, and there's another one called force type conversion. So basically for automatic type conversion, the compiler do a job for you. They convert the verbal type automatically. Or for force type conversion, that means we explicitly writing the type conversion code. We're asking it to be converted. So this is written by us, force type conversion. Also known as explicit type conversion or typecasting. Okay, there's an explanation here. So automatic type conversion occurs when the compiler automatically converts types during operations. Or force type conversion would be to manually changing the variable type before performing operations. So this is written by us. Let's look at an example. Integer a equal 3 times 3.14159. What would be your guess? What would be printed out if we were to print out variable a? So you can try it by yourself. You can make a guess first, and I'm going to execute it. It's 9. Does this meet your expectation? Should it be 9.3, 9 point something? But this is just 9. This is not 9.9 or 10 point something. So why does this happen, or how can we solve it? How can we make it a floating point number? So let's continue. What's the reason behind our demo? Here, 3 times 3.14 something is converted into 9. So what's the reason behind it? Let's look at the explanation. 3 and 3.1459 have different type. So remember, 3 is an integer, while 3.14159 is a floating point number. They have different type. And while doing this kind of calculation, the calculation is multiplication. Compiler automatically change their type. So 3 will be converted into floating point number, and this will be 3 times 3.0 times 3.14159. But still it's weird, right? Because just now the output is 9. Why is that so? So this is calculated into 9.4 something. But then when we are storing this 9.4 something back inside our integer variable a, they have actually different type. This is a floating point number, while a is an integer. So actually integer has lesser storage space in comparison to a floating point number. So floating point number cannot fit into the integer storage space. So of course, this cannot be stored correctly. So this floating point number will need to first be converted into integer in order for us to store it as an integer. So 9.42 something will be converted to 9, the integer 9. So a gets a value of 9 as we have demonstrated here. So the upper part is actually automatic automatic conversion. but then here there's another type called explicit type conversion. Okay, let's say we define a float variable a, and we assign 100 divided by 3 to a. What is the expectation of the output? It's 33. Why? First, let's try this by ourselves. 100 divided by 3. And we are going to print it out. And it's 33. It's not 33 point something. Oh, wait, it's a float. A is a float, but still it's 33, it's not 33 point something. Why is that so? The reason is 100 is an integer. 3 is also an integer. So an integer divided by an integer returns an integer. So we are going to assign an integer to a floating point number. So that's correct. But here the output of this calculation is 33 because when an integer divided by an integer, the output is still an integer. So the decimal points are all lost. In order to make it correct, to make it work as our expectation, we can explicitly convert this value into a floating point number. For example, can convert it into a floating point number. And let's run it. And now it's 33.333. How about we just convert 100? We are not going to convert. The 3 is still an integer, but 100 has been converted into a float. Now it's still 33.333. Why is that so? Because if this is a floating point number, and then the right side of this operator is an integer, during calculation, this integer will be converted into floating point number. So a floating point number divided by a floating point number will still be a floating point number. So the decimal points preserve. Also, it's the same if you convert 3 only and not converting 100. It works the same. Okay, how about there is also another type. How about we convert the whole thing, 100 divided by 3. We convert the whole thing, what happened? Let's try it. So it's 33. Why is that so? Because we are only converting this value inside it only after these are being calculated. So this integer and this integer, the calculated value is still an integer, 33. So now if we convert 33 into a floating point number, I mean, the decimal point is lost already during this calculation. It's lost already. So even if you convert this 33 into a floating point number later, the decimal is still lost. So we shouldn't do it like that. We should do it like this. And when you write a float and a parenthesis explicitly, this is called explicit type conversion. So this is the rules for it. First, you write your data type. It's not just float. It can be any data type like integer. Or we have double, if you remember, we have double or Boolean. So it can be any data types or maybe not any, can be most data type that can be calculated. And then cover your value with a pair of parentheses. Also take note that the value on the left side of equal cannot be perform explicit type of conversion. For example, we have A. Now we're going to reassign A equal, let's say A is an integer. A is integer. We are going to assign A to be 1.12. Does this works? So from what we have talked about just now, it doesn't work, right? Because A is an integer. You can store floating point number in an integer. So floating point number will be converted into integer first, and then so only number one will be stored inside A. But then you are thinking about how about I make A a floating point number? How about that? It doesn't work. You cannot change A dynamically. Cannot change the type of A dynamically. Because A is already defined as integer. You cannot change the data type of it anymore. So it will always be integer. Always remember that. Okay? So you cannot explicitly change the type of your variable at the left side. However, if you if you convert the type of your variable at the right side is allowed, for example. So let's say A is some value, right? And A is an integer. Now we have a B, it's a floating point number. We're going to calculate A times 1.2. And we want A to be a floating point number. So we can explicitly convert A to a floating point number. This is allowed. Okay. And try to print out B. Yeah. So this is all about automatic type conversion and explicit type conversion. So basically for automatic type conversion, you don't have to do anything. The compiler will handle it for you. While for force type conversion or explicit type conversion, you have to do the typecasting by yourself. You have to write the code explicitly. So you have to write, for example, float or integer or boolean explicitly by yourself and cover your value by a pair of parentheses. Next, we'll talk about binary. So maybe you have heard about it. In computer, we use binary number very often, or let's say binary is the basic representation of computer language. And why is that so? So what is binary? First, what is binary? Binary is just, that means 0 or 1. It's a mathematical concept. Binary means our value, this data type either 0 or 1, like a Boolean value. It's something like binary. So why we use binary so often in computer? It's because computer is built by circuit or by some electronic device. So, or actually it's transistor. Transistor is an electronic device. So this transistor has, like, for example, has two states, either on or off. Either there's current going through or either there's no current going through. So it's very intuitive to represent these kind of states in binary formats. If there is no current going through, if it is off, then it gets a value of 0. If there is current going through, it gets a value of 1. So that's the reason behind why we use binary numbers so often in computer. And you don't really need to know this kind of binary expressions for programming, but it's good to know them. So for example, if I give you a bunch of binary number, for example, this binary number has 1, 2, 3, 4, 5, 6, 7, 8. Have 8 character or have 8 character, and sorry, have 8 digits. So what is the decimal representation for this binary number? Change it to base 10. What is the decimal representation for it? So the formula for it is 1 times 1 plus 1 times 2 plus 0 times 4 plus this digit times x plus this digit plus 16 times 16, and so on until this digit plus 128. So the decimal representation for this binary number is 27, which is 1 plus 2 plus x plus 16. I'm sure you have learned this in mathematics class, right? I remember during my time, I learned this kind of conversion in my mathematics class. So I hope you know this already, to convert a binary number into a decimal number. And while for decimal number, we can convert it into a binary number as well. How can we do so? We can continuously divide 53 by 2 and obtain a remainder to get a result. So first, yeah, divided by 2 and obtain the remainder to get a result. Thing is, you can look for it. Decimal to binary. So would looks like this. You have this 100 dividing by 2, you get 50. Divided by 2, you get 50. Divided by 2 again, you get 25. Divided by 2 again, you get 12. And this time, the remainder is 1. Divided by 2 again, you get 6. Divided by 2 again, you get 3. Divided by 2 again, you get 1. And this time, the remainder is 1. So we can add up all the number with remainder 1. So it would be like, would it be? Oh, okay. So this is the binary format, the binary representation of 100. 001, 001. Or is it correct? Oh no, it's 1, 1, 1, 0, 0, 1, 0, 0. Yeah, 1, 1, 0, 0, 1, 0, 0. But you get the idea. This is the formula for it, to convert a decimal number into a binary number. And I remember that this actually works for any kind of base conversion. Let's say if this is not base 2, it is base 3, you can divide it by base 3 as well and concatenate all the remainder. And now you get the representation of 100 in base 3. Next, we are going to talk about operand size. What is the operand size? So, for example, previously we talked about integer or floating point number, and we are saying about they have different, their storage have different sizes. But what exactly is their storage? So in computers, the storage is actually this kind of binary number. Our integer or floating point are actually storing as binary value in the storage. And what is the smallest storage unit of memory? It will be bits. What is a bits? So this is a bit. A digit is a bit. So a digit can either be 0 or 1. So these are bits. And 8 bits from 1 byte, for example. There are 8 bits over here. So 8 bits from a byte. So 32 bits will be 4 bytes. And just as we have talked about, 1 bit is 1 digit in our binary number. So a bit can only store either 0 or 1. And so a bit can store either 0 or 1. How about 8 bits? How many kind of states can 8 bits store? So it can store 2 power. So if you have 1 bit, it can store 2 power 0 states. If you have 2 bits, it can store 2 power 2 states. So this can store 1 digit can store 2 power 1 kind of states. So 2 digits, 2 binary digits can store 2 power 2 different states, and so on and so forth. So if you have 8 digits, it can store 2 power 8 states. And 2 power 8 is, and 2 power 8 is 256. So we can store 256 states. And why is this important? So you need to know that given different storage space, there is limited data that they can store. For example, if you remember, last time we talked about character cannot represent Chinese character. Why is that so? Character can only display all those characters defined in the ASCII codes. Why is that so? Because character, in order to represent Chinese characters, the binary representation for Chinese character is quite long. It's longer than 1 byte. Character has only 1 byte. It's longer than 1 byte, so it cannot fit in our character, the storage space of character. So we cannot store a Chinese character inside this character type. And in case you need to store Chinese character, maybe you can make character a white. You can create a white character type. So white character type have 4 bytes. So it fits. So Chinese character can fit in. Now you know the reason why we can store Chinese character here in the most basic character type. Okay. And before that, it's saying that, not sure where's this. Oh, this one. Okay, Boolean. Boolean consisted of 1 byte. Character consisted of 1 byte. White character, 4 bytes. Character 16, 2 bytes. Character 32, 4 bytes. So what does this 16 means? 1 byte would be 8 bits. So 16 So this means 16 bits would be 2 bytes. 32 bits would be 4 bytes. As you can see here, 32 bits would be 4 bytes. So integer 4 bytes, long 8 bytes. About floating point and double. Float is 4 bytes and double is 8 bytes. So that's the reason why we're saying that double can, although float and double can both store decimal numbers, but double can store longer decimal numbers. It can store it more precise. Because what is the reason behind it? Because double has larger storage space, so it can store longer thing. Also, there's a long double, it's super long. Can store decimal numbers very precise. And then there's an example. Let's say if integer have 4 bytes, then how many number can be represented by the if it is 4 bytes? So it has 4 bytes mean 32 bits. So this is a representation for a visualize. Let's visualize it. So this is the 0 bit, or the first bit, the second bit, or the third bit, and the 31st bit, and the 32nd bit. So the 32nd bit is special one. We use the 32nd bit to indicate whether this number is a positive number or negative number. Okay. And then we left with 31 bits, right? How many states are in this 31 bit? There are 2 power 31 states. There are 2 power 31 states. And minus by 1. This is just yeah. And now we know that we can store maximum this number in integer. If you are interested in how we calculate this 2 power 31 minus 1, what is the reason behind this? If you not really understand, you can maybe search online. This is about counting how many states can be represented by multiple bits. For example, the keyword you can search for is states in a bytes. There are 2 power x. So this is actually a math question. Why there are 2 power 31 states? And okay, so there are 2 power 31 states here, right? But then there is a minus 1. Why there is a minus 1? Because we have 0, remember we have 0. We can represent 0. So we have to handle this 0 as well. So the maximum number we can handle will be this. Okay. And let's talk about error message. So there are 2 types. There are many kinds of errors actually, but they can be categorized into 2 main types. One is syntax error, another type is semantic error. And for syntax error, that means your code cannot be executed at all. Cannot be compiled and cannot be executed. Why is that so? Because you are missing semicolons or parentheses or some kind of imports. Maybe you didn't write your, for example, maybe you didn't write your namespace correctly. Maybe you didn't include your dependencies correctly. So your program won't be able to compile and execute. So this is called syntax error. How about semantic error? Semantic error means all your syntax are correct, but your code is not working as expected. Some of the logic is not working as expected. This is actually this is like logic error. So yeah, for a syntax error, the most common error would be semicolons and missing semicolons and parentheses. And for semantic error, I mean, other than syntax error, you can say everything is semantic error. That means your logic is not executed as what you expect. So that's an example. Include error stream using namespace standard. And there's an integer a. If a greater than 2, print out something, return 0. Is there an issue here? Yeah, there's I'm not sure what is the issue here. Oh, there is a missing semicolon. Yeah, a semicolon is missing. If you run this code directly, it will throw error. For example, if I run this code without a semicolon, it throws error. It's telling you expected comma or a semicolon before cout. And how about another example? A equal to 1, if 1 smaller than A and A smaller than 3, cout something. So what is the error here? The error here is that you are missing the curly braces. So there is an opening curly braces for it, but there is no closing one for it. Okay, there's an open and close here. There's an open, but there's no close curly braces here. So curly bracket must be a pair. And thus this is all about chapter 2. We have talked about, actually we talked about quite a lot of things. Arithmetic operation, logical operation, relational operator, and also if statement, else statement. And also we talk about binary representation. We talk about type conversion. Type conversion got 2 types, automatic one and an explicit one. Yeah, so that's all for chapter 2. Next week, I think we'll talk about probably switch statement. It's similar to if statement, but it's similar to if statement. Yeah, we'll talk about switch statement for next week. And let's take a 5 minutes break. And at 10:05, we'll start going through some of the exercises and homeworks in the platform. So see you later at 10:05. Hello guys, welcome back. Let's take a look at the classroom exercises and homeworks. Let's go through it together. So this is from last week, so let's skip it from last week. This is talking about divided. Okay, it's also from last week. It's talking about remainder. So it's also from last week. This is from last week. This one, let's try to like memorize it, or you have your way to remember it. And this is very important. We use it a lot in if and else statement. And yeah, this is logical operator. And we talked about it already last week. Okay, so this gets to the focus of today. It's about if. Please design to allow the user to enter a number. If the input is 7, display and grade. If the input is any number other than 7, do not display anything else. So if it's 7, display something. Otherwise, do nothing. Right? Otherwise, do nothing. So if this is number set, so first we can define a number, and then we read a number. See in number, we read the number. If number equal 7, we print out something. Otherwise, do nothing. So otherwise, remove this code, do nothing, and submit, and we pass. So if you run it, let's say if you enter 5, so do nothing. But if you enter 7, it match. So I am great. Next, Cyclops has $N left in his pocket. Please design a program where the user enters number N. If N greater than 50, print it milk. Otherwise, print it bread. So this is a very classic if-else question. If N greater than 50, print out something. Otherwise, then it's if it is else statements, then else print out something else. So you can run it. If it is, let's say if it is 49. If it is 49, it's not greater than 50, right? So we run the else case. Eat bread. Eat bread. How about if it is exactly 50, what happened? Exactly 50, still it's not greater than 50, so still eat bread. How about if it is 51? 51 is greater than 50, so eat meal. There's another one. Cyclops has $N left in his pocket. Design a program where the user enters number N greater than 0, eat meal. Greater than 30 and smaller equal than 50, eat bread. Otherwise, not enough money. So this is a classic example of if, else if, and else. 3 kind of statements. So first, if N greater than 50, we do something. Else if, otherwise given another condition. So this is the another condition. If N greater than 30 and N smaller equal to 50, then we do something. Otherwise, if none of the above match, we do something else. So this will be an else. So this structure is like if a condition, else if another kind of condition. Otherwise, none of the condition above match. Otherwise, we do something else. So let's say if this 52, but if this is 52, will be eat meal because it's greater than 50. What if it is 32? Let's say 32. It's not greater than 50, but it's greater than 30 and smaller equal to 50. So it break. What if none of this match? Let's say it's something lesser than 30. Let's say 20. If 20, it doesn't match the first one. It doesn't match the second condition either. So it matched the last condition, otherwise condition, which is not enough money. Submit it and pass. Look at another sample. This design a program where a user enters two numbers, A and B. If A greater than B, print A greater than B. A smaller than B, print A. So this is very straightforward. Given two numbers, first we define two numbers first, and then we read number A and number B from input. And now we can compare it. First condition, if A is greater than B, then we execute something. Else if given a second condition, else if A is smaller than B, then we print out something, execute something. Otherwise, given none of the above match, otherwise, we print out something else. Let's try around this. Let's say your A is greater than B. Let's say A is 4 and B is 5. B is 1, B is 2. So A is greater than B. It prints out A is greater than B. What if A is lesser than B? A is 2, B is 4. So A is lesser than B. What if A is equal to B? Let's say A is 2, B is also 2. Then it prints out A is equal to B. Let's submit this. Please design a program where the user enters score. If the score is equal to or greater than 60, display OK. Equal to or greater than 70, display medium. Equal to or greater than 80, display good. Equal to or greater than 90, display great. Otherwise, display fail. This is basically a question to train your if-else skill. So if the score, we can write, if the score is greater equal to 90, then do something. Otherwise, do something else. The second condition, greater equal to 80, do something else. Else, greater equal to 70, do something else. Otherwise, if none of the above match, then it's failed. But in the beginning, maybe you will try to write like this. If score greater equal to 60, see out. Okay. Else if score greater equal than 70, see out. Okay. Sorry. But this logic is incorrect. This logic is correct. This logic is incorrect. Why is that so? Because let's say if you have your input is 80, still 80 is greater equal to 60. So this will be executed instead of for example like that. Okay, let's say you have number 70. If you have number 70, still the first one will be executed because the 70 already is greater than 60. And thus this won't be executed. But we want to execute the upper, so we want to execute the upper part first actually. If it's 70, we want to match it first and then we print out medium. Okay, so we need to play around with the order of this logic. And thus, we have to check whether it's greater than 90 first. If it's greater than 90, do something. Otherwise, we check whether it's greater than 90. Okay. And so on and so forth. So this is a sample, the example we saw on the slides just now. Boolean consisted of 1 byte, character 1 byte, white character 4 bytes, character 16 2 bytes, character 32 4 bytes. But don't worry, the common one we'll be using is Boolean. We will use Boolean, character, integer, float, and double quite often. But other than that, these are lesser used. White character 16, character 32, I use it very, very rarely. Short also I use it, I rarely use it. Integer, long, sometimes we use long or long to store a very long number, a very long integer. So to store a very long integer, you can use long or long. Okay. And there's float and double. And there's long double. I seldom use long double, but I use float and double quite often. So this is all about the exercises. Let's take a look at the homeworks. So Cyclops is not very good at calculating dates. This refers to the fill in the blank questions program and design its functionality. Initially, the user enters today's date as the week 1 to 7. They enter a number of days past and the program calculates the day of the week for that day and prints it in the form of Monday off to Sunday. Oh, this is an interesting question. So I enters today's day of the week. For example, I enter 1, which means Monday. And then I enters the number of days past. For example, I say 30 days from, I enter 30. That means 30 days from today's, what will the day be? If today is Monday, 30 days later, what will the day be? This is the question of this, is the question for this homework. So actually, so first we read in a day, which means today's day, okay, a day. And then how many days have passed? For example, 30 days has passed. After 30 days has passed, what is the new day? Is the new day still a Monday, or is the new day a Tuesday or Wednesday or something else? Okay. How can we calculate? So this is actually a mathematics question. And from our current day, let's say if our current day is Monday, Monday is represented by 1, right? But I want to make it 0 to 6. I want to make it 0 to 6. So that is easier for calculation. So I let my day -1 first. So that I map 1 to 7 to 0 or to 0 to 6. So I let day -1 first and then I plus n. That means from Monday, let's say Monday, plus 30 days. And then modular of 7. That means I want to get the remainder after all the full weeks have passed, what are the remainder? Okay. And given the remainder will be the actual day, right? For example, if the remainder is 3, that means it's Wednesday. Okay. It's not really Wednesday because I mapped it to 0 and 6. So 3 is Thursday. So if the remainder is 3, and I'm going to plus 1 because just now I mapped 1 to 7 to 0 to 6. So I'm going to plus 1. So it would be if this calculated to 3, the remainder is 3, plus 1, so it would be Thursday. Okay. And So we can use switch to map the day, to map our new days to print out Monday, Tuesday, Wednesday, Thursday, Friday. Wait, let me check. Is this a switch question? Oh, so it's this question wanted to make use of switch statement, but we haven't touched on switch statement yet. I think next week we'll talk about switch statement. So, but switch statement and if statement are actually the same thing, but maybe sometimes switch statement make your code cleaner, looks cleaner. For example, in this case, so switch case means given a new day, if new day is 1, then you print out something. After you print out something, we want this program to exit from switch statement. So we write break to exit from switch statements. And then for similar for all of the other case. And then there is a special one, default case. Default case means none of the above match. In default case, we can do something as well. And then after we do something, we can ask can break, means breaking out from this switch statement. So don't worry if you don't understand anything about this switch, because we haven't touched on it yet, and we'll talk about it next week. So it's actually the same as if statements. For if statement, we will need to write something like this. It's less cleaner than switch. If new day equal Monday, new day, sorry, print out Monday. Else if new day equal to, then we're going to print out Tuesday. And then there will be a lot of else if here. New day equal 3, print out Wednesday, right? And okay, I'm not going to type 4, 5, 6, 7. And then we can have a default case. Let's say for default case, default is actually else. So for default case, print out invalid day. Yeah. So if we convert this switch case into if else statements, this would be it. And they are actually the same thing, just that they looks a little bit different, but they are the same thing. And switch case makes your code look cleaner on some scenarios. For example, in this condition. And let's try to run out. But first, let's try to run our code. If today is Monday, what? 2 days later, it will be Wednesday, right? Yeah, Wednesday. How about if today is let's say today is Sunday, 14 days later, it will still be Sunday, right? Yeah, it will still be Sunday. So this is all about this question. About next question. Next question is about increment. We talked about this a lot last week. Skip it. This is also about increment. We talk about it a lot. And this is also about this plus thing. And okay, we talk about this as well. This is for calculating remainder. So we go through this last week. Yeah, this is all the exercises and homeworks for chapter 2. Next week, we'll start to talk about what we'll talk about next week. Probably we'll talk about switch statements. And maybe we'll start talking about loop as well. For example, for loop or while loop. So stay tuned next week. This is all about this is all for today. Thank you for listening. See you guys next week. Bye bye.